Okay, so let's move on and let's take a look at how we can now use Punnett squares to show how alleles may combine to produce a zygote. And this is the same idea as using a genetic diagram, same idea, but we're going to make it even easier by just making a little box. So same thing, we're trying to find the probability, not the actual number of offspring that will have it. So in this scenario, okay, you've got, again, that individual here, big B, little b, crossed with this individual, big B, little b, and then these are the possible outcome. The same idea as before, the total is 100%. Each box represents 25%. Okay, so let's try this out. I'm going to do one first using looking to find out to do the prediction on male and female phenotypic ratio. So these represents those X and Y chromosomes. So when you draw this, you draw a box. Okay, again, this is the mom mating with the father. Again, those X's will go into her gametes. So there's one egg, there's the other egg, and then these X and Y will go into the father's sperm, so showing his gametes and Y. And then in this case, a little bit different from drawing the genetic diagram, you just match these up. Big X and big X, or whatever, X and X. And then in this case, you have X and X again. And then down here, you've got the X and this time a Y because it's the egg in the X in the egg and the Y in the sperm that fuse. And then for this one, same thing, big X, little Y. So when we talk about the phenotypic ratio here, it's definitely a 1-to-1, okay? So there's a 50% chance that you're getting a female and a 50% chance to get a male. So like if you look, ideally around the world, globally, there should be about almost 50, the population of the world should be almost equal between the genders, male, 50% male and 50% female, 50% male and 50% female. Okay, let's look at then an example that with using the same crosses from earlier. I'm going to do A, and then for B, you guys would do B after this inside that virtual lesson. Inside the virtual lesson. So let's cross then big A. So this individual, big A with little a, and then little a with little a. So we should get the same genotypic and phenotypic ratios as we saw earlier, even using this method. So let's say maybe father's up here this time, mother's gametes or eggs are down here. Let's match these up. Okay, capital letter always goes first. Okay, if you're wondering where I got those letters from, I'm just matching them up. So little a there, little a there. So when you look at this, okay, remember this big A, little a there. You can see again that there's 1, 2, big A, little a, and 1, 2, little a, little a. Again, we can reduce that number. So the genotypic ratio here, it's going to be lazy there, is a 1-to-1. If we look at the actual, again, phenotypic ratio, it's the same thing. So whatever these two, whatever big A, little a is, it's going to result in, again, let's say that was for black hair. I know the letters don't match up. So 2 black hair individual compared to 2 blonde hair individual. All right, so reduce the numbers again. The phenotypic ratio is, okay, a 1-to-1. All right, you're going to do the other one on your own, and then we're going to come back to our lesson. All right,